And so we are going to kind of look at an overview, spend the first half of the day looking at these and gradually zoom in on things that are practically related to mobile app development in particular. But I'm going to start with the description of some 7 phases of the system development lifecycle, the major software development strategies, and then the reasons behind choosing one strategy versus the other, and then the differences and advantages, pros and cons with each of these, and ways in which we can improve on these development life cycles, and how we can make sure or improve the rate of success for software projects. And mobile app development is a type of software project, and which is very common today, right? Which startup, which company doesn't want to have a mobile app, right? It's a presence that everyone needs to have. And so, but if you look at today's landscape, or if you look at the landscape of software development in the last 2 decades or so, or even longer, you will see that success is not always guaranteed. Okay? Because there are a number of factors. It's not just technical factors. Coding perhaps is the easy part. But besides coding, I'm going to show you that the majority of failure is not due to the coding itself, but other factors behind coding. So there are non-technical issues, such as executive commitment and leadership, which you may or may not have influence, right? And then there's planning, right? How thorough the planning is, both from the business and technical side. And of course, there's skill and experience of workforce, right? You try to develop a mobile app, how much experience, and whether you can recruit the skilled workers, developers, into a team, right? To deploy those to the iOS and Android platforms, right? And then the management focus and project monitoring, willingness to make changes and adjustments. Okay, and we'll continue to talk about some of these through our life cycle discussions. But I'd like to show you some statistics from this 10-ish chaos report. And this is a group that does research to give reports and advisory to inform people about software development performance. Okay? And they use very extensive research to understand how many the ratio, the statistics of success and failure, and what contribute, right, to the success and failure of these projects. And roughly they release a report every 2 years or so. I would like to kind of go through the timeline, starting all the way from 1990s to early 2000s, and then 2010, and then up until this decade, to show the statistic that changes over time. Okay, perhaps you can see some pattern, perhaps you will see some justification why this is the case. But in 1995, when they sampled 300 software projects, they reported only about 16 of those projects completed, right, on time and within budget. So this is success. 3 kind of key measures, right? You have to be completed on target, right? What you try to achieve, and then on time, and then within budget, and then that means only 84% of projects actually failed in one way or the other. Now, fast forward to 2009, right? You can see there's an improvement, right? 32% completed on time within budget, but still majority, 68, almost 70% of projects failed. Now, 2014 report, 39 successful software project, and you see, it's improving over time. 43, right, challenge, 18 failed. So it looks like the main trend is improving, but then you look at 2020, and it says that almost 84% of IT projects fail, right? So now this can be confounded because we feel like perhaps has been improvement over the years. And I would like to attribute, and my personal observation is there are a lot of things that happened during this period, okay, during the last 2 decades or more. One is the methodology. And remember, in the 1990s, the success rate, I would attribute that to the methodology. Because back then, the kind of the mainstream methodology was this waterfall method, which I'm going to discuss later. And it was at the end of the 90s when I graduated from college. And when I started my first job, I was very much on this, follow this waterfall methodology. And I can tell why it failed, okay? Because it was just not able to adjust to changes and misunderstanding and engagement with the user. So I will talk more about that. And so in the 2000, right, if you look at 2009, okay, there was an improvement. And I would like to say that perhaps part of the contribution factor is really methodology, because I think during this period, there's a adoption of the Agile methodology, just to have these iterations of software development to incorporate changes faster. And that perhaps explains why we see an improvement here. But then what about 2020? So, I mean, perhaps it's still part of the methodology, because I think, with the Agile methodology and with the kind of a lean startup, I think failure now perhaps it's not necessarily a bad thing, because many projects actually, even startup, they want to fail fast, right? Fail quickly so that this is not going to work and you can pivot, okay? So that can be perhaps the shift of kind of a different way of thinking. But anyway, there are lots of factors going into why projects succeeded versus why they failed, right? So attributes such as user involvement, right? Factors of executive management support, clear requirements, proper planning. And then there are challenges, related to these, right? If you are not able to really engage the user and get their feedback, get their input in the design, perhaps you are designing your system or application for the wrong user, right? Incomplete user requirements and specification, changing requirements, and this is the very common thing, right? When you are designing it, if it takes a while to release and finish the cycle, the requirements may have changed. People's needs may have changed. And so you need to change the specification, you need to change the design, right? There are also others projects that are ultimately impaired or cancelled due to incomplete requirement, lack of involvement of users and resources. But when you look at kind of the different aspects of product failures, you can see that less than 40% is due to the code error, the problems in the code or in the programs itself. Okay, the majority comes from the other factors: design, documentation, requirement. Right. So these are very serious and very costly. Now, how can we develop these systems, right? And make it successful, right? So there are 3 keywords here, okay, that I want to emphasize. Now we want to follow a systematic, disciplined, and quantifiable approach to build certain type of information systems, including, of course, our mobile apps, right? So And we need a more formal approach, a process of engineering in order to make it successful, right? And so these are the, 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 the steps, right, as part of the procedure that should be taken into account. The requirements, design, instruction, test, and maintenance, right? This is really representative, the list here is representative of the process of the phases in the software cycle, right? Requirement being the initial stage in software development life cycle where users can articulate and the design team can collect and analyze and specify and validate the requirements, right? And then once you have the requirement, you translate into the design, right? To create a design which should include the architecture and details to support the requirements. And then from the design, you translate that into the actual implementation, right? The detailed software architecture, the solution, the programming language, the specifics, the functions and things in order to implement the design. And of course, that will come with tests. And there are different levels of tests that I will kind of also talk about. And then when it goes into the production, into the operations, it's maintenance. And there is also cost and associated with that. Okay, and so this is the whole system development life cycle, from planning to analysis to design to development, testing, implementation, and maintenance. This is associated with the 5 phases that I talk about, as some are more fine-grained. Okay, and this is kind of also representative of the thinking of the waterfall methodology, because waterfall, why it was initially proposed was because it follows exactly what we need here, right? Because waterfall says you need to do planning, you need to collect the user's requirement and then analyze it, and then design, and then develop, and then test, and then implement, and then maintain. But then, and we'll talk more about that, but then you will need to remember, and my first software project, and I will talk more about that later, was also a project for a very traditional industry to develop a scheduling management system for the industry following this waterfall model, following exactly this process. But the problem with that process, just very briefly, is that when you get to the point of development, it's already a couple of years later, and you realize something's wrong with the requirement, the basic design. And at that point, it's kind of too late to go back. Okay? And that's part of the reason why many software projects fail. Now let's kind of break down each of the individual steps to see what we need to focus on, what we need to do in each step, and then step back to that, look at the methodology. We're going to look into the waterfall, into other methodologies and things that we can consider for our development effort. Okay, so planning, the goal, of course, is to define the business need, right, for the project and assess the importance for the company and determine whether the project is actually feasible, right? There are considerations from the business side in terms of return on investment, competitive advantage, risk management, right? So, and then of course there's also feasibility, studying whether this is actually doable, is it going to kind of survive. And then analysis, right? You need to understand the process, perhaps create diagrams to represent those processes, define the requirements, and from a pure business point of view, right? You can consider to build it internally or to buy it, right? Acquire it from someone else, right? And the output of this is the requirement definition document that specifies in detail what features the system should have, and then what should be prioritized by the stakeholders. This is actually a picture that I really appreciated because there are so many projects to which I can connect the kind of the storyline to. So, because this really summarizes how different we are when we're in the different roles as users, as designers, as developers, as the one IT manager who maintains the system, we see it from all different perspectives. So how the customer explain it, right? You understand, and then how the project leader understood pretty basic, right? And then how the analyst design it, but on paper it's going to work, but not in reality. How the program wrote it, okay? Not even anything that the user wants, right? How the business consultant describe it and make it a kind of a dream case. I see this all the time. How the project was documented, documentation, is, and then how version install, when you install lots of issues suddenly arrive, right? And then how the customer was feel. Yeah, I can tell that. Especially for the company, first company that I work with, it's all about kind of giving them the big picture and then charge them for big money, and then delivery is the secondary thing. And then how it was supported, right? But the customer really needed. Very simple, just make it work, right? But I think it's a huge divide here. Okay, I want to use this. This is kind of a very old example, but I always like this example because it makes the point. Got the straightforward. Like you all know these guys, right? Paul Allen and Bill Gates, the two co-founders of Microsoft, right? I'm sure you knew about their success story, right? Their first product is for this, right? For the first PC. But this first PC, Altel, is really incapable because you see it's a PC, but all it has is like the LED indicator, the lights basically, and then the switches. The switches are your input, right? The binary input 0 and 1, and then the output is the lights. Okay, again binary, right? And so it actually has some computing capacity from Intel, but it doesn't itself. When it was built, it doesn't support any programming languages yet. And Bill Gates and Paul Allen created the language basics, right? That runs on that, and that started their success, which they continued into the development of Microsoft DOS and the operating system and so forth. Microsoft today, the rest is history. But my point is not really about the kind of how big or how good they are, but it's really when they created the first system, the programming language for this box. These two guys did not even touch the box there. They created simulators, and on top of the simulator, they created a language. And now when they translate to that box, and it worked the first time when they were testing at the company. So my point is their success is because they understood the user requirement, because they themselves are the users. They are programmers. They were creating a language for the programmers. So they knew exactly what the users were looking for and designed that system for them. So that was kind of the perfect case in which you are the user, you understand what they need, and you create that system for them, also for yourself, right? So that is kind of some things related to user requirements. And sometimes that is the case, right? Sometimes it happens that way. You are creating something that you are passionate about. You really want that because you know you have the user, right? You don't see anything else, you just want that. And so you create that kind of system. And lots of startups kind of start that way, right? Now, from analysis, right, you want to go to the design, the architectural design, data models, right? And so the design phase captures all aspects of how systems, components, or function together to accomplish the goal, right? Using descriptions, models, and diagrams. I think I realize we do not have time to get into some of the data models but perhaps next week we'll come back to some of these when we design our components, especially when we integrate some backend APIs and databases. I think we need to look at data models as part of the implementation design. Okay, and then version control. And today, actually, we're going to kind of delve really deep into version control because Git, right? GitHub is really the distributed version control system, but version controlling is super helpful. Over the years, I have used so many different version control systems for Microsoft's. They call, what's the name? Safe source. And then there is the previous version for C. The current version system, CVS. And then there was Subversion. And then currently, of course, Git. Right? So Git is really the last iteration. And one thing Git is really good at is most distributed version control. So you can manage repository locally at different branches and then allow you to merge and then resolve conflicts. If you happen to work on different team members work on the same code file, right? You need to be able to resolve conflicts, which is a huge feature in this version control system. And then, of course, as part of version control, the project issue tracking, which is super important. And so, second half, you are going to do all of these: version control, project issue tracking, and code review. Okay, hopefully, if we have time, I have 3 different iterations for that activity. We'll see if we have time. If not, we can continue next week. Okay, so that is for the development. And then there is testing. Like you of course, when you are developing, you are testing yourself. It's more like, okay, I as a developer testing the basic functioning of what I create, the feature, right? But as part of the feature, there may be smaller elements inside the feature that requires unit testing, right? Basic computation of that small component. And so unit testing is very important to make sure that the functionality of a small module of code actually function as it should be, right, during the development phase. And then there's system testing, right? Both end user and IT staff test the functionality of the entire system. There is, of course, stress testing. Of course, stress testing is important for certain types of systems, especially you want to serve many users, right? There should be load and tests conducted, right, to assess how well the system performs under peak load, right? Because I'll talk more about it. I was the chief engineer in a major company in China. It was actually a US company, but a branch in China. When we created systems at that time, around 2000, we were serving millions of users, visitors every day, right? So you have to be able to scale, right? When it comes to very small things, like do we save this to a flat file or to a relational database system, there is a huge difference in load. We have to be constantly aware of what the implication is when it comes to stress testing. So very important when you are serving a large user base, right? Parallel testing. This is more like, okay, you are creating a new system to replace the old system. You want to be able to compare, right? If the old system has been functioning correctly, even though it's not its best, you still want to replicate the functionality. So hopefully the result should be the same. And then there is integration test, which is important because that will allow end user and IT staff to test the new system's interfaces with other components. Because it's not just this alone, but when we put this component in the context of other components and link to each other, does it continue to function? Right? It's very important. And then acceptance test, right? And this is ultimately, of course, about the money, right? If they do not accept, they are not going to say, okay, we accept and approve, and we are going to send you the rest of the money, right? So the end user perform final testing to determine whether the project is complete as specified. Okay, so testing and then the final implementation from the development into the production, right? And so there are different ways in which this can be done. It can be done in parallel where the whole system is still in place. You phase in, you implement the new system, or you can gradually phase out the whole system and intro while introducing the new system, or this is more drastic, direct replacement, okay, which of course is more risky, but certainly if you are confident and there is an urgency to really get rid of the whole system, this ultimately can be also one choice. But it really depends on the situation, right? And then finally is the maintenance, right? Which is the work needed to support changing business requirements. And this is always the case, right? Change is the only constant today, right? Anything will change or evolve over time. And so there will be bug fixes, right? Just to fix the existing problem, but there will also be change required, right? Information systems will continue to evolve to fix the bug and respond to changing conditions. And also changes may also be due to the evolution of other technology. Right? Just look at the development environment they installed a few weeks ago. Perhaps now you need to update them, otherwise it breaks or something is outdated, and you will say, don't call this interface, right? Replace with the new one. And so these are changes that we have to deal with constantly. So there is this whole notion of aging of your system or the app that you develop. Okay, so the ultimate question, which is very important, is that does these systems evolve? And of course, you see the answer is yes, to one degree or the other. So any process of information or growth, right? So this is the definition, but software evolve, they age, and so I just want to show you this because in the age of AI, I think we need to. There are actually multiple levels of kind of evolution or change because we know programs. Imagine it's just a program. We provide fixes and updates, so they change over time because of the fixes and updates. But these are considerably minor, right? Minor or moderate changes. And data we know will always change, right? We constantly generate new data or change existing data. And so this is another dimension to it. But ultimately, today we also have AI models capable of learning, right? Whether it's ChatGPT or Gemini or other cloud AI, other models. These are language models that are capable of being trained and fine-tuned, and so they will continue to learn, right, and adapt. So adjustment. So these models are essentially adjustment based on data. They can be trained and fine-tuned, and they can adapt to the new environment. And I suspect perhaps in the future you will have programs that can adjust their code and reprogram themselves, right? And so perhaps I'm not sure whether it's going to get even more complicated or it's going to save developers time. Software agents, they can improve on themselves. So based on the user feedback, right? So that would be wonderful. So a need to maintain information systems because of everything, all things considered, right? There's always this evolution aspect of software systems, right? They change rapidly. And so we need to be able to evolve software in a reliable way. And here is also an estimated number regarding the amount in terms of cost, right, in software for just to account for the evolution for the changes in software. Okay, so this is a huge amount that we should expect, right, for software or system that you create over time. So yeah, so I can tell you maintenance is a very costly job, especially when it has been years, and so that's why like legacy systems has been a number of years in there. The developer probably are gone, even the skills that you need for those systems may not be there. Right? It's hard to recruit, and even if you can recruit, to put people back on the position to review the code and be able to understand, and before they can even put their hands to revise and update, it's a huge challenge. Okay, now let's kind of talk about the software development lifecycle model specifically. Okay, so a development lifecycle model defines a set of activities for developing information systems. Who is doing what, when, and how, develop information systems in a more planned and structured process. Okay, so this is really to follow the phases that we outlined earlier, right? So that we will be able to finish the entire project successfully. And so the waterfall, as the name suggests, really goes from one stage to the other, okay, and follow the phases from requirement to design to implementation to testing, installation, and maintenance, right? And of course, initially it was just one directional, and then in the end, come back. Okay? But I mean, through generation, they also add feedback. Okay? But the methodology really failed in so many fronts because the integration of this feedback loop is not that easy, not simple to incorporate this feedback. Okay, but it does logically follow the step from the sequence of steps. Okay, and but the problem is when you make a mistake in one step, okay, it will cascade into the downstream steps. And then, but more important is that because they don't assume that you go through many cycles to finish the project. Normally, it's like waterfall is one cycle. And so when you plan for a 3-year project, okay, when you are doing implementation and testing and you face a problem in the requirement, you are already 1 year or 2 years into the project. So it becomes extremely challenging to address issues. So it's simple, straightforward sequence of phases, right? And it supports function-oriented project organization. And kind of really, there's a whole pipeline here. It looks like it's rather structured, and people should be able to follow. Okay, but it is really inflexible, right, to requirement change. Okay, because design is based on requirement, development is based on design. Okay, if you want to change one, that means a lot has to change, and it's a lot, indeed a lot. And as an engineer back then in the waterfall model, we hated changes because it introduced so much work. And so the long development duration, right? Because it assumes that one follows another, and so each stage takes a long time. And when there's a problem, it becomes too late. And users really could not experiment with the system, right? It's kind of at the beginning, it's just promises, right? Promise you, we are going to have a great system, right? It's a dream, but then you have to wait 3 years. And the dream will come true, but in the end, normally that is not the case. Right? So users really cannot touch on anything and provide feedback. And this is very important, early feedback. Right? And that is something the Agile methodology tries to address early on. So the customer has to wait until the entire system is implemented and deployed to reap the benefit, if there is any benefit. Right? And customer lose the entire investment if it fails. And there are many cases in which it does fail. Now, so there are some methodologies that have been proposed to address the issues in the original waterfall model, right? The iterative approach. So with this approach, kind of a reversion, you can revisit previous activities during iterations of the project. So this is kind of a more advanced version or revised version of Waterfall. And some of the models fall in this category. So spiral model is also going through iterations of changes. Right? So we go through a cycle is really a cycle of the different phases. Right? From the initial analysis, okay, to development, to the next one, okay, and then ultimately it also incorporates the prototype development, so which is really addressing one issue in the Waterfall, which is the user does not have a chance to provide feedback. But with prototype, you do have a chance to at least show the user something, and they will be able to give you some feedback. And so this can be improved on the Waterfall a little bit. But in the end, I think it's still Waterfall. So it goes through iterations, and then in the end, like assume the feedback has been collected, and we are on track, and then we'll continue most likely with the Waterfall. Okay, so that is the spiral. So it's a series of risk-driven prototypes and a structured waterfall-like process. Okay, so multiple feedback opportunities with the user and customers, and typically does not have enough time for full concept presentation. And it's simply just a couple of prototypes, not like, okay, millions of prototypes, or in today's common project, like many prototypes, or many working systems. Right? Just a couple, and then it's Waterfall. Okay, so that is still very much just a revision of the Waterfall. There was also this rational unified process model, and so it's really broken down into two dimensions. One is about the phases, like from inception to elaboration, to construction and transition. And then there are disciplines, which are really about the different activities that you should conduct. From business modeling to requirements analysis, implementation, test, and then management and environment. So, and you see that some of these can be connected to the phases that we discussed earlier, right? From planning to analysis to implementation. The improvement over the Waterfall of this model is also that, you see, during each phase, there are also iterations. Okay, you can break down each phase into iterations into smaller steps, and then plus, you also see that during each phase, for example, we are in the construction phase, you see the focus, there's a lot of activity related to implementation and testing, but there's still some, even though reduced activity related to business modeling. So it's still a combination. So all activities or disciplines, I should say, are still there in each phase. Okay, so you don't totally focus on development, totally focus on planning. There's a little bit of everything during each phase. So that, in a sense, also incorporates this kind of feedback, because during development, if there is a problem related to business modeling, this feedback will go there and adjust. Okay, so that is the notion of rational unified process model. And so, but the key here is really there are disciplines and iterations. So an iteration is a sequence of activities with an established plan and evaluation criteria, resulting in an executable of some type. A discipline, the activities associated with the development of the software, right? A set of activities. So inception, I don't think we need to get into this model, because this is really not the model we want to spend a lot of time talking about, but we can kind of discuss some of the advantage of this unified model and better adaptability of requirement change, because the requirement can be refined successfully over time, because each phase there is the activity all the disciplines, so that change or adjustment can be made. Okay, and this better scope management, multiple executable iterations can be deployed by the time the deadline is reached, and the last may even be deployable. Okay. So now that we're getting into agile software development, right, from traditional software development, because one major issue that we have seen in the traditional software development process represented by the Waterfall model is that it does not easily, it's not that it totally rejects change or feedback, but it's so difficult or time consuming or sometimes too late to incorporate change or feedback in that process. So Agile is just as the name suggests. Of course, there are many methodologies, specific ones that are different in minor ways, but in the Agile category of technology or methodologies, the focus is really on individual and iterations over processes. So we are not going to put in the process just to restrict people from giving feedback, but rather we are going to make sure that individuals will have input and they will be able to make changes and incorporate feedback over time. And then also putting working software over comprehensive documentation, which, I mean, as a developer, you will love this. Right? You want to make something work, not just focus on, of course, nobody enjoys documentation. But good documentation is a great practice. But it's not just because of that. It's really, in the waterfall, when there's so much time spending on talking to the customer and documenting it, oftentimes they lose sight of what is actually feasible in the system. Because without a working system, even the customer, even the stakeholder don't really understand what it means, right? What features should be in there. And I'm going to offer some very real examples in my industrial experiences. But this working software, right? It's kind of a live demo, right? That you can touch, you can see, and you can immediately criticize, right? It's not working, and so this is working software over comprehensive documentation, and then customer collaboration over contract negotiation, right? So of course, this has to be a change of paradigm. But it's important one. And responding to change over following the plan, right? So again, in Agile, it's almost like we don't want a plan. We don't want is to reject over planning. Like we know change is our constant, and we have to just live with the change. Okay, and so instead of following the plan as if there is nothing to be changed, we are going to kind of work with the change and respond to the changes during the execution of an initial plan. Okay, so these are Agile principles, okay, I proposed early on, and I will just highlight a few things, the priorities to satisfy the customer through early and continuous delivery of valuable software. Welcome changing requirements, very important. Deliver working software frequently. Okay, so in my class, usually it is related to software development and programming, right? Sometimes students turn in code that doesn't work. Okay, I would totally completely reject that. You have to make it work, and everything else, But students sometimes complain, like I put in so much code, doesn't make a difference. It doesn't work, right? So I mean, what matters to the end user? If you are on the real software project team, right? The customer sees nothing except when the system is working, and so you have to be able to deliver working software, right? And frequently, so that changes can be incorporated and can continue to come back the feedback, right? And then, of course, the business people and developer must work together, and this is actually very difficult, okay? But in the kind of the hardcore agile methodology, you meet together, but also you meet face to face, okay? And you build projects around motivated individuals. Give them the environment, give them the support, and trust them to get the job done. Okay. And of course, they focus also mostly face-to-face conversations. Today, I know because of COVID and other things, it actually changes. You know, the Scrum stand-up meetings, and they will have to do it virtually. So there is kind of adjustment made necessary because of the new reality. So the working software is the primary measure of progress. If there is no working software, there is no progress, right? And sustainable development, right? This is to be promoted, and then continuous attention to technical excellence, simplicity, right? Maximizing the amount of work. Also, I mean, this is recognized that the best is also always from the self-organizing teams. So at regular intervals, the team reflects on how to become more effective. So you look back, you know, because of this constant iteration, there are times for you to always reflect on what has been achieved, what you failed, and then adjust accordingly. Okay, so that is Agile principles in the nutshell. I would like to talk about some of my experiences throughout the project that I worked with in the industry before I came back to graduate school. So some of the companies that I worked with, all of these were in China when I was in Shanghai. I was in Shanghai for 10 years. And so I worked with this company, probably don't know. It's called Lycos. Around year 2000, I worked 3 years for Lycos, which was back then, it was the first commercialized search engine in the world. And when I was working for Lycos, it was a multi-billion-dollar company. Nowadays, nobody hears about it. Right? So that means how fast technology changed. Back then, I can confidently say that Google was a little guy. Google started in 1998. But the first time I saw Google's result, my colleague sent me the link to Google and check this out. Immediately I knew it's going to take over. Our own results really sucks compared to what Google can offer, because my area nowadays is actually information trade-off, my major focus, search engine. And so, I mean, Google really shine in two areas. One, coverage, because it has covered so many things. Like when I used our own company search engine, I was not in charge of the search engine side. Otherwise, probably I would push to change something because it's not really working. But our company's own Lycos search engine was not comprehensive enough. Like I was searching for something I know on the web, but I wasn't able to find it with our own search engine. But with Google, I know, at the time I was able to find it. This was one, coverage, much greater coverage. And the second one is relevance. Like searching for things that should really just be at the top, right? You're searching for something, it's at the top. That's what you're looking for. And that was the case for Google. So, I mean, it's a very simple idea that really works. This is not information tuber class, so I'm not going to talk about the details, but it's really a very basic idea that makes all the difference in Google make the case. So, just within a few years, and totally took over. And I worked with eBay, and actually was hired to implement the payment system of eBay China, with like the PayPal in China. But that project was also a failure. Actually, the first project, the first company I worked with was a failure. The last company I worked with eBay, that because they both follow this traditional waterfall model, very structured, and it spends lots of time just to collect the user requirements. Sometimes it's totally completely kind of almost impossible to communicate, and then get it wrong and everything else. wrong. So for the first company, for the first project, I want to use this as an example to show you because, we were implementing a scheduling and delivery system for a milk company like dairy. Okay, they have delivery every day. And so there was one guy in charge of the whole scheduling system. So they have a big room, and the only purpose of the room is like there's a big wall, and they have the huge schedule on top. And this guy was like writing, scheduling things around the city of Shanghai with a population of more than 10 million, and this was the number one, the monopoly. And so they have, a huge system, but that wall was the scheduling system. And our company at the time was kind of won the contract to create a digital system to replace the system on the wall. But I mean, we talked to this guy, and what he wanted to do is basically to replicate something on the screen, the wall. And so that was the requirement. So first of all, when I look back, we talked to the wrong guy. The company should not have to say, okay, this is the only guy. At least this should not be the only person we talk to. There are other stakeholders. Actually, if our information system had been successful, this guy probably would have lost his job, right? Because the system would take over and we don't need you to write on the wall anymore, right? So it's very important to bear in mind the person who is in charge of the current system may not be the person who, right, you should talk to understand the new system, right? So even the company itself doesn't know what the requirement, what the feature the system should have, right? So, and of course, follow the waterfall when we have the wrong requirements and everything else, right? A couple of years into the project, there's just no way to go back and say, let's fix the requirement issue. Okay, so that was a complete disaster. Okay. Now, I do want to talk about my experience with this company, even though this company today is a very small company now. Compared to Google, we used to be the big brother of Google. But the systems we created back then was rather successful because even though Agile was already proposed, we had basically had our own Agile methodology. So for one thing, we had really small teams. We had small projects, small teams, and on the teams, we only put like 1 or 2 developers on that team. And then, of course, they talk directly to the developer, the product manager, to the content manager, the stakeholders of those systems that they need to use to serve millions of users out there. So they were in daily and sometimes even hourly communications with each other to really understand the requirement. And so and put that into the design and implementation. So that was really the key to success. So we created lots of systems based on this lean methodology, really small teams, really focused, and then many iterations. Not because we wanted to go that way, but we are also in a sense forced to, because in the .com company, you are forced to catch the deadline, to catch okay, we really have to get this out, otherwise our competitor will kill us. Right? So we have to get this out next month. And the only way you can do it is let's work within 1 week or 2 to at least deliver something and let the product manager take a look and make sure this is in the direction. And then next iteration, we're going to make it better very quickly. And if it doesn't work, we have to completely change our design and implementation. Okay? So that was, in essence, also Agile methodology. And very lean, small teams. Okay, and so we created lots of very successful projects, and then based on these projects, we also aggregate and get feedback, and when we reflect on these smaller projects, we actually were able to create even more larger scale by integrating all these together into a more kind of refined and larger scale systems. So that was a success, kind of in a sense following the Agile methodology. And then when I spent 3 years here, and then when I was hired to eBay, we created a payment system. Again, the structure of the organization is still very much in this waterfall methodology. And today, I understand it when I look at the eBay system. If you take a closer look at what the eBay system is, a very outdated system. I know the reason why it's so outdated because the way of developing and updating is just not really up to date. They should have made it more agile. Because when you look at eBay, it's still very much in the Microsoft or Wasabi, the Microsoft's web API system. It's really outdated. It was initially created in the 1990s, think about it, and now they are still using it. So that was some of my experiences, and I would like to talk about just in the next 10 minutes or so some of the methodologies and concepts that I really appreciated. I think you should also know when you get into development. So, Agile methodology, lots of concepts are nothing new. They're in the sense of old wine in new bottles. Okay, so I mean, we even borrow methodologies from the car manufacturing company. Toyota is number one, really. You know, the notion of Kanban. You know, if you have been on agile teams, I mean, Kanban is kind of a dashboard where you can look at things together. Okay? It's actually from the factory floor of Toyota. This whole notion of Kaizen, right? In Chinese or in Japanese kanji, Kai means change, Zen means good. So, which means change and improve. Okay, and it's kind of constantly change on the floor, right? From this task to this person to the next. If there's something wrong, they will immediately go back and provide the feedback. And so that's why Toyota quality is well recognized, right? So the methodology is very important. Kaizen, Kanban, these are very important. Now, in Agile methodology, this stories, user story is very important. Like in traditional software development tool sets, we usually say, okay, let's create use cases and data models and things like that. But in Agile, it's more like user story. Just on the index card, write in paragraph of an example of what the user needs. Right? What is he or she going to do? Right? What to accomplish? Right? So you can say, as a student, I want to be able to create an app in the classroom with Apple license, okay, or as simple as that, right, on the Mac computer, something like that, right? So you specify the role, specify what you need to do, and perhaps some dependencies and conditions, right? That is a user story, very simple. It's just in natural human languages, okay, and of course the dashboard, different types of dashboard, including Kanban. These are things that really help Agile teams to stay focused and be able to iterate very fast and improve. There are also a couple of meeting styles that I really want to emphasize. Of course, we're all sitting here and walking, but in Scrum technology, right, stand-up meeting is kind of the standard, right? The notion of stand-up meeting because you are meeting in person. And really, when you stand up, it's kind of also a gesture of engagement, right? Not like sitting back and just passively attending a meeting. It's like really engaged in conference. So this has been kind of a popular method out there. Of course, now because of COVID, they do use virtual and because of remote teams, of course. But I think in person is still the best. But in contrast to this, I do want to bring this picture back. I'm not sure if anyone recognizes this picture. Any idea? No, never seen this picture?
Which one?
Which one? This one. But basically, what are they doing? Do you know this group of people? For all the technologies in this classroom, everything that you are working with today, we should thank this group of people. Because the technology of Apple, the GUI user interface, the mouse, of course, our trackpad they're using, the networking, local networking, the PDF, Adobe, everything. all the ideas come from this group of people. You imagine that? They should be the #1 company in the world. This is Xerox Corp. Xerox is a copy machine company. This is in the 1970s. And this was their brainstorm session. Basically, they call it beanbag conference. They just lay back and on the beanbag and criticize each other. Because the beanbag, perhaps they just feel free to say anything. And so, I mean, if you just look at the stories, of Steve Jobs or Bill Gates, right? Steve Jobs, when he first time went to see a demo, right, was to this group of people. And they give him a demo, and immediately, right, the next day, so basically he said, we stole technology from them, right? And so Microsoft did the same, right? And Adobe is still here. The whole notion of local network, they have the prototype in the late 1970s and early 1980s, right? Which had everything. That of course, it's not as good as today, but they have the prototype of the screen display with the local connection, and you even connect to a printer in the local network. You can print out, and then this whole notion of what you see is what you get. Because word processing is not like I change the font and immediately it changes. It's like I put a mark in there, and then when you put it, you will make sure it will change it to a pixel size. But back then, they already have the technology to like, if you make it a larger size, it's going to show you the larger size on the screen, right? And then this whole mouse, right? The mouse, when they present it to their executive in New York, they are in California, but the leadership management was in New York. They presented the mouse, and they were laughed at because like, what is a mouse, right? The kind of weird device. But anyway, I mean, how creative this group of people were. It's amazing. If the company knew how to capitalize on their ideas, I mean, they are for sure bigger than Microsoft, bigger than Google, bigger than anything today. They are basically going to be the monopoly today. And so the purpose of this exercise is for you to engage in a team environment for mobile app development and to communicate about the app requirement, design, and work distribution. Okay, and the work that you are going to work on is in the first link. So I will talk a bit about it, and then you will also get familiar with the Git workflow concepts and practice. Particularly, I think we are going to start with something really simple first, with a decentralized workflow. This pull and then push, and hopefully there are no conflicts, and you can just merge and that's it. When there are conflicts, then you need to resolve conflicts. So I imagine two scenarios in which you will have no conflict versus having conflict, and you will deal with those differently. And then we'll get to more of a branching. Okay, you are going to create different branches, and then once you're done on your branch, then you are going to do pull request and then code review, revision, approval, things like that. And ultimately, we'll also talk about, if we have time, like the production versus development branches, and this is what is usually done in the real teams. And then issue tracking as part of the exercise. I think you will, to some degree, as part of the code review and revision, you will already be using part of the issue tracking features on GitHub and how to resolve problems together as a team, right? So you're going to form a team of 2 to 3 members and then continue each of the following slides. Each one is one iteration as a team. And so in the first iteration, I'm going to go through everything and then come back to the first iteration, and I will let you do it. So I imagine each iteration is about 15 minutes for the class time. But of course, if it takes longer, that's okay. We can always adjust. So first iteration is the initial team setup, right? So you're going to review the team requirement, app requirement together and design together. That's why if you're sitting together closely, I mean, it makes sense to that way. And then you need to appoint a team leader. Okay. So team leader is going to be in charge of setting up the initial team repository. So you're going to create different separate repository and then grant permissions for the members to be able to contribute to the same repository. And then of course you can initially create a React Native Expo project within that repository and then some initial code and files and folders. And then you also want to discuss distribution, like okay, we have these components that we need to create for this particular app. Which one is going to do which, right? Tasks. These are the major responsibility, but of course, things you can discuss. Okay, and then the team leader working together with team members is going to design and create basic components for the app, and then be able to push all changes to that repository as a team. And team members will check out for repository and make sure everyone is on the same page. So this is kind of the initial setup, okay, for the team. Any questions so far? Okay, if you do, just let me know. And then the second iteration is to really work together as a team using the centralized workflow, okay, on the Git. So assume everyone is on the main branch, and by default, if you just clone the project, okay, and get it on the local machine, it's going to be on the main branch, okay. You don't do anything. And this is the first step. So if you're there, each team members work on a feature, right? You coordinate them. Okay, I want to work on this particular to-do item. Focus on it. Implement some basic, code for the feature. Make sure, of course, test it. Make sure it works, right? And then, starting with the team member, I want the team leader to be the first one to commit the change and push to the repository. Okay, that's the core main change from the team leader. Make it a main app, basic code, push to the repository, okay, and then followed by each member at a time, right? So the second member wants the team leader to push. I want to do it that way, control it, so you see the process, right? Because in the real world, you just, I just commit and push individually. The other person, he or she may commit earlier or later or at the same time. It can happen that way, but in here, you just observe how it's going to work. Okay, so team leader commits and push, and then another team member will commit and push. And at that time, probably you will need to merge. There's a change from the team leader, there's a change from you, you need to merge. Hopefully there is no conflict, it's a very easy merge, and then everything will be in the membrane repository, and then the third member will also do the same. And merge and push. And you finish it. Now, this is kind of the first part of the second iteration, which is merge without any conflict. Because you each work on different files. Now, you can pick at least two members to work on the same file. Okay? So you make changes on one part of the code, you make changes on the other part of the code, and then see how you resolve the conflict together, and then merge, and then everything's good. Right? So that is kind of the second iteration, which has basically two parts. The third iteration is closer to the real world practice, which is kind of the branching. And so for each feature, usually when you are focused on a feature in the Agile methodology, it also makes sense for you to just single out, just create a separate branch, because while you're working on the feature, in the end you may abandon the feature. That doesn't affect anyone, right? But if your feature turns out to be working and good, then you can send a pull request like, okay, this is functioning, could you pull this change back, right? This most likely should be done by other team members or the team leader. Okay, and so each member to improve their own features, and each will create a new branch for that feature he or she is working on. Okay, so you can call it like, okay, to-do item feature, whatever that makes sense for you. Okay, for that branch. And then develop, of course, for the feature and test it locally. Once you feel like, okay, this is good, okay, test it, ready, commit and push to your branch. First, of course, when you commit, it's to your own branch locally. And then and push also to the branch remotely on the server. But then, because ultimately you want this not just in your branch, but be able to work with other people's changes in your branch. So you need to send some therefore merge into the branch. So this is something very different. You are working between the branches. Okay? So you need to send a pull request, and this can be done on the GitHub. On the VS Code terminal, you also can do that. The tutorial shows you on GitHub. Okay? And then, of course, for each pull request, okay, the team leader will have to review and approve. If it's good, just approve and then accept that, and they will merge that into the main branch. Okay? If not, if there are problems that you see, you can comment, you can say, okay, make changes, and then the other member can make changes, commit again and push again, and then you can merge. Okay, so there's this review, approve, and comment, and merge process. Okay, so this is the iteration number 3. There's actually ideally will be number 4, but I don't think we have time, which is there should really be a production branch or the main branch and the development branch. Okay, and then from the because the entire team during the development process is really on the development branch, and then from the development branch you have the feature branches, and then when you merge into the development, and then if everything integration test and everything is conducted properly and nicely done, you finish the big iteration in 2 weeks, and then you can push into the production system. So that is kind of the general workflow, but I think this will be at least give you some taste of this workflow. Okay, this is a discussion of React components and data models, but what I really want you to focus on is like, okay, this design, like you're creating a to-dos app, and then these are the basic components, the files that you can create, right? So, I mean, when you as a team discuss like what components and requirements and design you have, this is something you can refer to, okay? And then the team leader can kind of create the basic files, and then you can pick each member can pick a feature to work on, and then start this process following the steps to commit, push, merge, or resolve conflicts and merge and change.